Today we're going to talk about conditional probability. So conditional probability is used to find the probability of dependent events. It can also be used when additional information is known about the event. So the conditional property of B given A, and you can write it like this, it's the probability of A and B over the probability of A, as long as A is not 0. Okay, so this is the probability that event B occurs given that A has already occurred. So let's look at how this works out. Okay. So the Spanish club is having a Cinco de Mayo fiesta. The 10 kids randomly draw cards numbered with consecutive numbers from 1 to 10. Kids who draw an odd number will bring main dishes. Students who draw even numbers will bring desserts. If Cynthia is bringing dessert, what is the probability that she drew the number 10? Okay, so it's not just randomly, what's the probability she drew 10? We have additional information. We know she's bringing a dessert. Okay, so they're drawing cards out of this. So the way these work is it's the probability of success, so the probability we get a 10, which is 1, but it's not out of 10, it's out of the probability that she picked dessert, which means she got an even number. So that's 5 possible numbers. So this is going to be 20%. Okay, a blue marble is selected from a bag of 3 red and 5 blue marbles and is not replaced. What is the probability that a second marble will be selected will be blue? Well, if you picked out a blue, that means of the 9, there's 8 left. There was 12 marbles, now there is 11. So this is a dependent event for 72.2%. Okay, your time to try these two. So if a die is rolled, and if the number is less than 5, what is the probability that the number is 2? Well, there's only one number 2, and there's 4 numbers less than 5. So the probability would be 1 out of 4 if we can eliminate 5 and 6 as being options. Here, students are randomly drawn cards from 1 to 20. If they're odd, they're on red, even they're on blue. So if Monica's on the blue team, what is the probability that she drew a 10? Well, there are 10 cards that give you a blue team membership, only 10. So 1 out of 10 gives me 10%. Okay, so here we have a whole lot of rules that we've been talking about over the last couple of weeks. These are just kind of the definitions all in one spot here. So we're going to look at some different examples here. So according to an online survey, 56% of college students have a car on campus. Suppose 2 students are chosen at random from a group of 100 college students. If this group mirrors the population, what is the probability that at least one of the students does not have a car on campus? I'm going to show this to you in 2 ways, and you can decide what makes the most sense to you. Okay, my first way I'm going to do this is to look at really the 3 cases that at least one have a car on campus. So the probability that the first person has a car, the second does not have a car. We'll simply multiply those probabilities together. So if 50% have a car, 44% have no car. So I'd multiply has a car is 0.56. Does not have a car is 0.44. That gives me 0.2464. The second case is the first person does not have a car, but the second one does. This will be the same probability. Actually, these would be switched, but it doesn't matter. And then the last case is if both of them have a car, because it still qualifies as at least one of them has a car. So that's 0.56 times 0.56, which is 0.3136. If I add all those up, we get 0.8064, so about an 80.6% chance that at least one person has a car. That's one way to do it. The option 2, which is going to require less math but may not make quite as much sense, okay, is the only case that doesn't qualify for this is the probability that the first person doesn't have a car and the second person doesn't have a car. So that would be 0.44 times 0.44, which gives us 0.1936. So that's the probability neither of them get a car. That means every other scenario qualifies as a winner in this case. So if I do 1 minus 0.1936, I get 0.8064. So we still get 80.6%. So if it makes more sense to do it this way, you can do it that way. Or you can do the complement rule and figure out how many don't work this way to get this. All right, so the next two are very similar, and I'd like you to try those. Okay, so in this example, 55% have one student or one sibling. If you choose 2 people out of the population of a group of 100, what is the probability of at least one of the students having one sibling? So you can either add one has one sibling, one doesn't, twice, or they both have one sibling. You get this. Or you can find the probability that they do not have one sibling and then multiply those together and subtract from 1. So you should get 79.8% for that. 64% own a pet. So what's the probability that at least one does not own a pet? Well, owns a pet, does not own a pet. The first one doesn't own, but the second one does, or they both do not own a pet. Gets us 59%. So this is examples of conditional probability and just using different probability rules.